There we go. All right. So, like I said, welcome to class, guys. Make sure you have access to your Chapter 8 review questions because we're going to be looking at those, doing a little bit of review, kind of get you helped out and prepared for the test. If you have this chart that I attached to the Schoology post today, that's great. Open it, have it on your computer screen. I don't expect you guys to print this stuff out, but if you at least have it in the background of your computer screen. If not a huge deal. I'm going to have this. We're going to hold up on camera and go from there. So it's not a huge deal if you don't have it. All right. So some of the first things I wanted to talk about today, I wanted to review some basic threaded fasteners that was in that chapter. There's a lot in that chapter. There's a lot in that unit where we go over threaded fasteners, non-threaded fasteners. We cover different things like as far as a non-threaded fastener. Here's an example. Here's another example. Things like clips. That's a fastener. It holds things together, but it's a non-threaded fastener. Or cotter pins, where we take this, stick this through something, and turn it over. Those are non-threaded fasteners. But mainly my main goal while you guys are remote is to get you to understand threaded fasteners. And I know this isn't the most exciting thing in the world. People probably think, every time I do this lesson, they're like, I don't really want to learn about nuts and bolts. Well, you have to. You have to know nuts and bolts to be able to fix cars because you just can't go to a bucket, grab a random bolt, and throw a bolt in the car if you broke one or you need to replace or it was rusted or something like that. So you need to know how to put the right bolt in the car. If you need a new one, you need to, if you go down here, they used to call it the nut house, but the fastener shop or whatever it's called now down here in Latrobe, they can pretty much get you any fastener that you want. But if you walk in and say, I need a bolt, they're going to say, okay, we have a whole building full of bolts. What type of bolts? Metric, standard? Oh, I don't know, you're going to say. Or what's the thread pitch? What's the length? Is there a non-threaded shank? Is it threaded all the way to the end? What's the head size? Different things like that they're going to need to know. So it's nice when you can walk into a place and say, I need a 1/2 inch bolt with, you know, a 20 thread pitch that's 1 inch long, that's threaded all the way to the end. And they're going to say, okay, well, here's our options. It really, really helps them out and helps you out to get the right bolt. So it's really important to know this stuff. All right. Another thing is, that's why it's important, is to know torque specs and know how to torque them and how to tighten them, because different fasteners require different things. Some fasteners, when you look up in a service manual, it'll tell you to put a thread locking compound right here on the threads before you put the nut on. Some does not. Some bolts and fasteners say before you put them in to a cylinder head or an engine component, they may say lubricate with a special compound or a drop of engine oil. So it's good to know about fasteners. There's a lot more to fasteners than just bolting things together. You also want to make sure you have the right grade, the strength. If it's something that's just, you know, holding this top on this workbench behind the camera here, obviously it doesn't need to be a grade 8 bolt. But if it's something that is structural and, you know, they're putting bridges together, or there's something that's, you know, very important that it stays together and has a lot of strength to it, a grade 8 is a necessity or higher, or a higher grade. So you need to know that. One rule of thumb with grades, I always want you guys to remember, is it's always better to go a grade higher if you have to. All right, so I would never go a grade lower. If a grade 8 bolt came out, you want to put a grade 8 bolt or higher back in it. If a grade 5 bolt came out, you want to replace it with a grade 5 or better. All right, so get started with that. Talking about metric and standard. Let's just do the basic identifications of a bolt. All right. Do me a favor. You guys all type in that chat box up there privately. Change it to privately. So where you click that everyone, change it to me. Click in that box up there. How can you tell if it's a metric or standard bolt? What are you looking for? I'll give you guys a second. Take a stab at it. If you're wrong, it's no big deal. That's why you're here to learn. All right. Okay. All right. So, got a response in there. What I'm going to do is I'm going to go over this a little bit. The easiest way to know if it's a standard or a metric bolt. Standard sizes are going to be, obviously, when we talk about standard and metric, standard is, or SAE, is fractional sizes. 1/4 inch, 1/8 inch, 1/2 inch, 3/16, 5/16, 9/16, different things like that, right? Metric is going to be in millimeters, so 10 millimeter, 11 millimeter, 8 millimeter, 6 millimeter, things like that. So it's important to know the difference because whatever this is, this has to match. All right. So the easiest way to tell if it's a metric or standard bolt is we're going to look at the heads of the bolt. So when we're looking at the heads of the bolt here, we see some different sizes. On this one here, hopefully you guys can see that, it says 8.8 on it. When we look at this one, it just has 3 little hash marks on it. The 3 hash marks are going to tell you that it is, type in the box if you know, it's got 3 hash marks, or just hash marks in general. I'll give you 10 seconds. I like it. Response is coming in. All right. Grade 5, grade 5. Okay, yeah, it's telling you the grade, but is this telling you if it's standard or a metric size? It's just telling you that it is a standard or SAE bolt. All right. And you guys have said grade 5. You're exactly correct. I appreciate you guys, looking into that a little bit. But yes, this is telling you when I see those bolts, if I want to know if it's a metric or standard, all I have to do is look at that. I don't really care right now how many lines there are. I just know there's lines on it. That's a standard size bolt. So now I'm going to get the tools out to measure this in standard to figure out what sizes I need, right? If I look at this, it is a metric bolt. It's got 8.8. Metrics have the grade numbers stamped into it. Standard has the hash marks. All right. So when we're looking at our chart here, hold up our little chart, and we can see the English or inches and the metric and their equivalency. All right. So we're looking here. We had on this one, we have 3 hash marks. 1, 2, 3. So that's telling me that that's pretty much equivalent to the 8.8 here. That's telling me in English, it is a grade 5 bolt. In metric, that is a grade 8.8 in the metric grade rating. All right. So these two are equivalent. So some people get this a little confused and they say, oh, well, that's a grade 8. Well, not really. It's equivalent to a grade 5 in English standard sizes. Okay. So we're going to look at, let's see if I have another one here. I don't. I don't. I was going to try and show you a grade 8. I thought I had a grade 8 sitting here. But you just basically count the hash marks. And a good rule of thumb is there's 3 hash marks there, right? So you add 2 to that, it's 5. Always add 2 to the hash marks. So if you see down here, 1, 2, 3, 4, 5, 6. 6 plus 2 is 8. It's a grade 8. All right, so always a good rule of thumb is I always add 2 to the hash marks, and I'll tell you what grade it is. All right, in standard size. In metric size, it tells you the grade right on it. All right, so that's how you identify if it's a metric. If I just wanted to walk up and say, hey, one of you guys in class, hey, is this a standard or metric bolt? Or is this a standard or metric bolt? You would look at the head, and you would look at the markings on the head. All right. Now, same goes for, same goes for nuts. Most nuts, not all of them, have some sort of markings on them. This is going to be really hard for you to see here on the camera. But there's a mark there, there's a dash mark right there, and there's a dash mark right there. So there's markings on the nuts too that correlate to the fastener. So you want to be aware of that, okay? Hard to see. That one's got hash marks on it too, and it fits on a standard or SAE English bolt. All right. Here is a example of a metric nut. I don't know if you guys can really see it, but take my word on it. There's a number stamped right there. All right. Some of them will actually say metric on them. So there's different variations of that too for it, but you always want to make sure you can identify them. Now, when we talk about sizes, well, let's talk about these in general first of all. These are bolts. These are not screws. Sometimes you'll hear them called screws. Sometimes people call them screws. These are a bolt in automotive. We want to call these a bolt, all right? They use a hex head. You can fit a socket or a wrench on. When I say that go get me a 1/2-inch bolt, I'm not necessarily talking about this head here. I'm talking about this is 1/2 inch, all right? This, you can have a 1/2-inch bolt with different size heads that sockets fit on. So we're talking about this size right here, all right? If I say go get me a 6mm bolt or an M6 bolt, the metric bolt, we're talking about here, how wide this is, all right? The size of this, not necessarily this. So some of the other ends of that fastener, we've got a bolt. A bolt's main purpose is clamp something together and hold it together. It has to have strength, tensile strength, and it also has to have shear strength, all right? So they're rated differently. I don't know what the shear strength is right now on this 100%, but you can look that up on charts. That's why there's engineers that make charts for those things, all right? The other side of it, that clamping power, you have to have a nut. And in between the nut, you have to have various forms of washers. Very rarely, if ever, are you going to see a bolt and a nut installed without any kind of a washer on it, all right? Most of the time, it's going to have at least a flat washer. We call that a flat washer. And a lot of times, it's also going to have a lock washer. Put the lock washer on. And then we clamp those down, and we have a nice, even clamping force. This washer provides more clamping force. All right, that's why we always have some washers on a bolt. Now, back to the lock washer. It just looks like a washer that was cut and twisted. Well, it is. It's actually got spring tension on it. What happens is as that would tighten down, as that's going to tighten down on there, it's going to push this flat, which causes to put spring tension on this nut to kind of lock the nut on the threads, all right? It's going to keep it from backing off. So a lock nut is a must on most applications. It's going to keep the nut from locking off, or the nut from walking back off, all right? There's different times, just your regular nut we're talking about here. There are specialty nuts for various applications. There are nuts with a washer head kind of built onto it. Here's another example. There are what I call buddy nuts for nut clips. Sometimes if it's in a spot to get to, you can't get a wrench to, they'll have this clipped on something and the bolt will go up through it. So we call those a lot of times a buddy nut. Here's another example of a bigger one. And I thought I had a castle nut out here. Example of a lug nut. I don't have a castle nut out here, but I'll show you a castle nut when you guys get back here in the class. All right. Out here, I also have some lock nuts. So there's different forms of lock nuts. Here's a common style. It's hard to see on camera, I know, but you'll notice it looks like the ends are smushed over a little bit because they are. They basically take this and they make it. There's a machine, you can see there's marks on it. It squishes this and crimps this and just puts a little crimp on the end. So now, as this fastener goes through there, it spreads those out a little bit, but it keeps spring tension on those threads, so it keeps this from backing off. So that's a type of a lock nut. And another more common type of lock nut that you see all the time, this one that I just showed you, you see these style a lot on exhaust manifold bolts, things like that. Here's an example one right here. It's hard to tell, but it's all oblonged in there. It's kind of squished around. Exhaust manifold bolts, sometimes you'll see them on steering and suspension components like that on modern cars. Here's a common one now. I call it a Nylock. A lot of people call it a Nylock nut. but this is a Nylock Locking Nut, or sorry, a nylon locking nut with a nylon washer inside. It's basically just a piece of rubber or a piece of plastic inside there that when you install this, it bites into the threads. See if I can get it in there. It bites into the threads of the fastener and locks it into place. These are very reliable, and you're starting to see them very common on a lot of things. All right. So now we know some basic. I'm just giving you a crash course on this stuff, right? How do we know if it's a metric or standard? We know that. How do we know what the grade the bolt is? We know that. How does the nut and bolt go together? What's required? What is a lock nut? What is a lock washer? What is a flat washer? All right, and the reason you need to know this stuff is even the most trained professional technician with the most experience is going to need to replace fasteners at some point. They're going to break a bolt. They're going to have to cut bolts off because they're rust, especially when we live in the Rust Belt here in Western PA. Cars 5, 6, 10, man, you get in 20-year-old cars sometimes at an independent shop or older, you're running into some very, very rusty bolts. You might have to cut them off and replace them. You might have to re-thread, and we'll talk about that a little bit later. We'll talk about fixing some threads. You need to know what size the fastener is or was. So some of the measurements that you're going to need to know are the actual bolt size, all right, or the shank size. So there's a couple ways you can do this, and I'm not doing a crash course demo on dial calipers today. This is something that I feel I can give you a little bit of theory on the computer, but you're not really gonna understand it until you get back and get your hands on this. This is definitely something that when you get back in the classroom, we'll go over, we'll spend an hour going over, and I guarantee you within that hour, most of you will be learning this like you've been using this like you've been using it for years, all right? So this is what we could use to measure that bolt, all right? There's a veneer scale right there with numbers on it. And there's a dial. All right, we can use this to measure components like this. We can actually use this to measure components like this, inside, all right? And we can use it to measure depth. So like I said, I just want you to know this is a dial caliper. We'll go over when you guys get back in class how to use this. It's gonna be your best friend. I keep a good one in my toolbox at all times in my shop at home. I use it to measure seals, gaskets, nuts and bolts when I need to find a bolt. Instead of going over, I watch my buddies sometimes go over to a bucket and they'll sit there, or they'll be over at the nut and bolt bin and they spend 20, 30 minutes, 15 minutes poking around, trying bolts to find the size. I pull out a caliper, measure it, take a thread pitch gauge, and I'm over there in 2 minutes and I got a new bolt. So for today's purposes, we are going to use a digital caliper just to speed the process up. And it'll be a little easier for you guys to see sizes on the screen. I have them both here, and you probably think, well, Wortman, if you have digital calipers here, why do we have to use the analog dial calipers? Well, because everywhere you go work may not have one of these, and guess what? I'll tell you what. I have a really nice one of these that I paid a lot of money for in my toolbox, and I have a really nice one of these that I paid a decent amount of money for in my toolbox. Which one do you think I use more? This one. Because every time I go to get this one, the batteries are dead, or I don't have batteries for it, or there's something wrong with it. So I always end up using non-digital stuff because of that, but I have them because I thought it was a good idea. I have them here to help with the learning process. You guys can double check yourself using these, all right? So what we're gonna do is we're gonna zero this out. We are going to measure this bolt right here. So do me a favor, hope you guys can see that. Type in the chat box individually to me. Am I gonna be looking for as a metric size or a standard size? Give you guys a second. All right. Good job, Alex. Good job, Hunter. All right. Cool. Yes, we're going to be looking at this as a metric. So I'm going to go ahead and change my scale here, or to see, to millimeters. I have zeroed it out. We'll go ahead and take a measurement. You want this until it just barely has any drag. All right. Don't want to clamp it down on it. You want it till it just has a little drag. So what I've come up with, and I'll lock this down so we can see it. That's the measurement I had. 11.99 millimeters. 11.99 millimeters. So that's telling me that this is a 12, an M12 bolt, a 12 millimeter bolt. All right. Not the bolt head, but the actual bolt size. The shank of it is 12 millimeter bolt. All right. Now I'm going to reset this. 0. Turn that off. There's more to know. We need to know the length. Well, we can get a tape measure and measure the length. We can maybe even measure this one. It's like 120 millimeters. All right, so you would tell them I need a metric bolt, grade 8.8 bolt. That's a 12 millimeter bolt. That's 120 millimeters long. But there's still another measurement we need for them, another basic measurement, and that's the thread pitch. All right, and the pitch is threads per square inch. All right, so how many threads are space part? Is it a fine thread, which this is a pretty fine thread, or is it a coarse thread, which this is a pretty coarse thread? As you can see, this is more coarse. All right, so we know it's a metric bolt. I'm going to come over to my tap and die kit. I'm going to grab a thread pitch tool, and it's hard to see on screen, but it says metric right on it, so I know it's a metric thread pitch tool. I'm going to open this up so you guys can see what the heck it looks like. I know you've seen it on your pictures in your chapter, but I want to show you this semi in person, virtually in person. All right, so you open this up, there's all kinds of different measuring tools on it, right? And they have numbers on them. This is the metric one, so you're going to see like numbers like 1.75, 2.0, 2.5, things like that. And you'll notice that the teeth change. So we're going to figure out what thread pitch this is. We're going to take this and we're going to start putting these in here to see. About 1.25 maybe. Ooh, I was right, 1.25. Those are, I always call it, you build a mental database when you get experience. And, you know, a lot of times after you've seen a bunch of these, you can say, that's pretty close, probably a 1.25 thread pitch. And I was right. So it is a 1.25. Says it right on there. And what you do to do this is you take this, you set that right in the grooves. And you want to put that in the grooves, and it shouldn't be able to rock. They should sit all the way down where I don't see any light underneath of it, and it should not rock back and forth. So that's a 1.25. So we know, I'm going to write this down because I like to write numbers down because I don't remember numbers very well. 12 millimeter bolt. 12 millimeter bolt. It was, I think, 120 millimeters long, and it was a 1.25 thread pitch. Now we have a measurement we can take to the hardware store and we can get a bolt. All right. So it didn't take very long to do that either. I know it seems like it because we're demoing it and I'm explaining it, but once you get familiar with doing this, you have a thread pitch that fast. All right. So it didn't take too long to do that. You also may have where you run into, you have a bolt, but you need to go get a nut. Well, you could take the bolt to the store with you and sit there and try everything and waste a bunch of time, but I prefer to walk in to Bergman's Hardware in Blairsville, say hi to the guys at the desk, walk right down the aisle, go to the bolt and look for the numbers, see what I have, and then grab the nut that I need and then pay my 75 cents and leave. That's where these tools come in handy. If you can measure the bolt, you know which other size you need. If you can measure the nut, you know which bolt you need. All right. So you can do the same with this. You can measure thread pitch of a nut just by sticking inside like that. You can measure the inside area of a nut like that. Okay, so get you your measurements. You can walk right in and be prepared to get what you need and walk right out. All right. So I don't know about you guys, but I'm the kind of guy that when I go to the store, I like to go right in, get what I need, and get out. I don't want to be in there messing around any longer than I need to. I got stuff to do. So now you know how to do that. All right. So what I want to do now is I want to talk about some thread repair. Let me move my stuff here. Tools you're going to see. All right. And I'm going to do my best to try and move this camera around here. All right. So right here, we have a tap and die set. That's your basic thread repair tool set we're going to talk about today. If you guys get a chance, feel free to look up some information on Heli Coils and different thread inserts. There's a lot of cool stuff out there to repair threads. But once again, that's something when you get back here, you're just going to have to do this stuff. And at least you already have some of the knowledge of the tools, the theory behind it, what they're used for, and what the numbers mean on them. So when you come in here, I hope you guys can hit the ground running and start, you know, doing some of this stuff hands-on. Let me pull out an example of a tap. Let me pull out an example of a die. Let me get a good die. All right. There's a tap. There's a die. A tap cuts internal threads. A die cuts external threads. A tap would be used to tap holes in this workbench to thread something in, to thread a bolt into it. The die is used to put external threads on something. So if I needed to fix the threads on this, or I had something I needed to add threads to, if I was in a machine shop, they would use this to cut threads. All right. Most of the time in here, we are going to use them to fix threads or repair threads, damaged threads. They also have what they call thread chasers. Thread chasers don't fix. The way it was always explained to me was thread chasers do not fix damaged threads, they clean threads. So sometimes you pull a bolt out there, maybe rust, corrosion, old Loctite, crud in there, any kind of crud in there. A thread chaser will go through the hole or over the fastener and clean the threads up, get the dirt and everything out of them, so it's like brand new. A tap and a die, they will actually cut threads. That's why they're tapered the way they are, so you can start this in the hole. Once you get in there straight, as you turn it, you put cutting oil on it, you back it out, keep turning it in and backing it out, you will cut threads in that. They're very sharp. This is why you need to know what size fastener came out of the hole that you're trying to put threads into, because you will never see this on this camera, but take my word on it. It says right here that this is a 12 millimeter by 175. So if I had a 12 millimeter bolt by 175 thread pitch, this is what I would use. All right. When we get into Heli Coils, you'll see the instructions in the Heli Coils. There's special taps designed for each Heli Coil insert. All right. This happens to be the one I grabbed out here was a standard size thread on the die, and this says it's a 3/8 by 24. All right. And there's different tools to hold these. You can put this in here and use this to as a handle to turn it. You can use handle like this. If I'm just cleaning threads up, I prefer to usually use one of these because I can get it in tighter spaces. I even have some in my personal shop that you can take this handle off of and put a 3/8 drive ratchet in, get in a little bit tighter spot. If I'm cutting new threads into something, I always recommend using this because you can guide it, have more force over it, keep it centered a little better. And then on the flip side of that, for the die, we have a die holder. Put the die in here, you lock it down, and then you can switch this over something to rethread it. When I was your age, this is the kind of stuff that used to bore me to death. I was like, I don't really care about this. This doesn't seem that interesting. I'm just going to try my best not to break any bolts or strip any threads, and I won't have to worry about this. It seemed very boring and like a waste of time. And then I got out working after I graduated school, and I realized that how important this is. For example, if you guys go back on our Instagram page and you check some of the the highlights of the stories in the past. Over the summer, I was doing some work on my father-in-law's Suburban, and I went to remove the oxygen sensor. I pulled the oxygen sensor out. It's been in there for, I don't know, 180,000 miles probably. It's old. Truck's got 200,000 miles on it almost. I pulled it out, felt like it was coming out okay. As soon as I pulled it out, it pulled all the threads, well, most of the threads, out of the end of the bung. So I had to fix that. I had to fix some of the threads. I had to clean them up, and I had to use a tap to do that. All right. So I had to know how to measure what size the end of the oxygen sensor threads were, the pitch, all that, and I got a tap, ran it through there, cleaned them up enough that I could get it back on the road and going down the road. So now that I'm a little older, this stuff, like I said, it's probably not the most entertaining to you guys, but to me to teach, it's one of my favorite things to teach, and people always ask me why. It's tapping dies, it's nuts and bolts, it's drilling holes, it's putting threads in things. The reason I always tell them one of my favorite things to teach is because no matter what you do, even if you don't work on cars for a living, this is something that if you know how to do properly, it's going to save your butt more times than not. There's going to be a lot of times where, say you're working on something in your house and a bracket on your boiler and the bolt breaks off or it strips out. If you know how to identify the fastener, get a new one, and repair those threads, remove the bolt and repair those threads, man, that's going to save you a lot more money than maybe having to buy a whole new boiler. So it transfers over into a lot of different things in life. So that's why I enjoy teaching this. And when you guys get back, I can't wait to get you guys on the drill press and get you guys cutting and making threads and bolting things together and doing little projects, because you take this with you wherever you go. I've had students that have graduated that told me, this is boring, I don't want to do this, why are we learning this? I just want to tear engines apart, I want to do this. And I say, okay, we'll get there. But what happens when you tear that engine apart and the bolt breaks off? You can't just say, oh, I'm going home, somebody else fix it. You have to fix it. So, and I hold you guys to industry standards for the most part here as best I can. So if you break something off in a car here, you just don't leave it for me to fix. I make you fix it. It takes you a week, it takes you a month. I make you fix it because that's part of the learning experience. So the better you are at fundamental foundational skills like this, you will be so much happier in the long run. Those same students that said that have come back to me, and I've seen them out and about at shops that they're working at, and they say, Wortman, I'm so happy I learned to do that, because you wouldn't believe it. I work with 10 guys there, and there's only about 2 or 3 of us that can actually read this stuff and fix threads and stuff like that. So I stripped the bolt out in a cylinder head the other week, and I could fix it, you know. I had to put a time cert or a Heli coil in something the other day, and I knew how to do that instead of telling them, oh, it needs a new engine. That goes a long way, all right? So next thing is a thread file. We talked about thread chasers. This is the last thing I'm going to show you today with these tools. This is a thread file. This is not used for cutting thread. This is used for cleaning threads up, maybe damaging, maybe fixing little damaged threads. It's got 2 sides on it. It says what the thread pitch is right on it. It's hard to see on camera. This is a 1, this is a 0.75, 2.0, 175, and so forth. Put the handle on it. And what this is used for is, let me find the right one here real quick. Standard. This is only metric on this one. What did I say that was? A 125 I wrote down, didn't I? Yep, 125 thread pitch. Find the 125 thread pitch side. Hard to see, but they line right up. File teeth line right up with the thread. All right. So if any of you guys worked on anything up to this point, tinkering with, go-karts or dirt bikes or anything, bicycles, at some point I'm sure you've accidentally hit these threads and mashed them over a little bit. It happens. Not something that I'm going to say I've never done. It happens all the time. All right. That's when you can take this file and you can come across there and clean those threads up. If they're severely damaged, this isn't going to help you. But if they just have a little nick in them, you can take the thread file and clean them up. All right. Now, Next thing I wanted to go over with you guys, I wanted to review your review questions. So grab these if you have them, put them up on your screen, leave your chat box open, because what I want to do is I'm going to read these questions, and I'm going to give you guys about 5 to 8 seconds, and I want you guys to type in the answer privately to me in here. And I'm keeping track. I'm keeping track of who gets the most correct answers. Not that this is going to hurt your grade, but I'm keeping track for later, because when you guys come back, there may be some little prizes or something sitting here, some little freebie giveaway things that I've received. So I'm keeping track, all right? So you guys have this up. It's also hopefully going to help you guys on your test a little bit if you haven't taken it already. Number 1, what are the 3 groups that establish the standards for fastener specification? Tia, I like what I see. All right. I like what I see there. Good job. Give a couple more seconds here. In fact, you know what? Hey, Mr. Highlands, do me a favor. We're going to make a little game out of this. He's in the classroom. I'm out in the shop. So we're social distance. What we're going to do is when I call out who answered it first, you want to take a little note of that? Take a little note when I say it, because I don't think you can't see the chats because it's only to me. So I'll call it out. And whoever answers the most first correctly, when I call your name out, we'll have a little prize here. All right, so Tia got that one. Yes, the answer is C. What are the 3 groups that establish standards for fastener specifications? SAE, ISO, and ASTM. All right. Number 2, how can a person distinguish a metric fastener? Man, Tia on it again. All right, A, you got it right. Grade number on the head. That's how you can identify or distinguish if it's a metric fastener. It has a grade number stamped right on the head. Number 3, what are the 2 main thread pitch designations used for SAE fasteners? Tia, you're on a roll. B, you got it. UNF and UNC. That's Tia again, Mr. Highland, with Hunter Rochelle in second place. All right. I'll put Tia. Bear with me for a second, guys. All right. Number 4, snap rings. Snap rings, what do they do? Give you a couple seconds here. Do they snap rings fit under the nuts to spread out the clamping force? Are used to retain plastic trim pieces? Are threaded into place or fit in a groove? Hunter got that one. Good job. Don't worry, we're keeping track for your gifts. Number 5, when replacing a threaded fastener, where would you most likely find torque specs? Something we covered in here before you guys went, oh, got it. All right, Hunter with that one. Oh, wait a minute. I lied. They came in almost back to back. Tia won that one. Hunter, right in after that. All right. All right. Good job, guys. Number 6, when torquing fasteners, it is critical to Hunter. Got it. D, use the correct grade bolt. I apologize. Number 5, I don't think I said the answer. It was A, service manual. You look the torque specs up in the service manual. Number 6, Hunter got that one first. Use the correct grade bolt. B. Number 7, which threaded fasteners cannot be reused? This is kind of a tricky one and a very important one. Oh, close to you. Close. So close. This one's a little tricky. It's one that you probably haven't heard of before this class, but it's very common on almost all vehicles nowadays. Hunter, yep, Hunter came back with that one. Hunter said B, torque to yield. That's why I said, Tia, you were so close, torque to stretch. And to be honest with you, torque to yield bolt that's kind of what it's doing. That when you torque a bolt down, it goes to a certain torque spec, and then you take it past its yielding point, you're actually stretching that bolt. You stretch the threads and it kind of locks it into place. So you had the right idea there, just the terminology, the yield is what the textbook answer would be. You'll see there's a lot on cylinder heads. For example, most vehicles, you replace a cylinder head gasket and take a head off of a car, you're supposed to replace the head bolts because they are a torque to yield. You torque them down, you stretch them, and then once you break them loose, they're already weakened because they were used once, so you throw those away. All right. Flip over. What are we on here? Number 8, all the following are ways to avoid breaking a stuck bolt, except. What do we get for that one? Oh, Hunter with that one. C, you got it. Use a breaker bar and just keep increasing the torque. No, we don't just send it, all right? We don't just send it. All these other answers are ways to avoid breaking it. Use penetrating oil like WD-40, PB Blaster. We have a Rusty's brand here. It works really good. Let it sit for a while. Penetrates the rust, breaks things loose easier. Try both tightening and loosening the bolt. Sometimes if you snug it a little bit and then loosen it back up and snug it and loosen it, it'll come free. Use an inductive heater to heat the bolt up. That's, you know, they're great tools. I love it. In fact, I'm going to order 1 or 2 of them for the school here. We had them at a dealership that I worked at. It was great because in areas where you can't use a torch, oxyacetylene torch to heat the bolt up, maybe around rubber bushings, around a gas tank. I've had gas tank bolt straps that were rusted and I couldn't get them loose. I'm not really going to use a torch on a tank strap. I'm not that crazy. So I would use the inductive heater where I could take the inductive heater, stick the coil end over top of the bolt or the nut, hit the button, and then electronically heats that coil up, and it'll heat that bolt or fastener up cherry red, just like a torch would, but it doesn't have an open flame then. All right? So that's a way of doing it. But like I said, the answer is use a brake bar, just keep increasing torque. That is not the way to loosen a stuck bolt. All right. Number 9, when using a thread insert, dun, dun, dun. I wish this was like an iPhone and I could see the little dots of people typing. D, Hunter got that one. Got it right. Hunter was in with it first. All right. D, the thread insert replaces the damaged internal thread. So when using a thread insert, the thread insert replaces the damaged internal threads. Sometimes the threads are so damaged you can't just clean them up. You actually have to drill the hole out bigger, thread it for an insert, thread the insert into it, and now you have the original size. That's other terms you've heard them called Heli Coils. That's a common brand. They work great for a lot of things. If you're doing engine work like head bolts, I've had to do it on GM, the 3.4 liters and 3.1 liters, 3100 engines, V6s back in the day. Sometimes we pull rocker arm studs out of the aluminum head, and we would drill them and we'd install time cert in them, and they'd be fine. All right, but I wouldn't use a Heli coil on maybe the rocker arm because it's not as strong of a thread repair, but a time cert, a thread sleeve like that works really well. All right, so whichever type you're using, it's used to replace the damaged internal threads. Number 10, all the following can be used to remove a broken bolt except what? Tia got that one. She was quick on the keyboard on that one. And then Hunter came right in behind. Tia won that one, though. They both got the right answer. It's A, use a new bolt to push the old bolt out. All right. Make a note of that. Man, you guys were like back to back. But Tia was a little bit quicker on the keyboard. All right, so all the following can be used to remove a broken bolt except use a new bolt to push the old bolt out. I've never seen that work. I've never tried it. Not going to work. All right, but you can use a screw or a bolt extractor. You can use a hammer and a small center punch to get prepared to drill the fastener out. You can use curved channel lock pliers or locking pliers to grab it and try and twist it out. Those are all acceptable ways, except for using a new bolt to push it out. All right, number one in the Tech A, Tech B questions. The reason I have Tech A, Tech B questions for you guys is that's industry standard. You guys go take ASE tests. I know you guys see some of my ASE certifications around here. We are an ASE accredited program, so I am expected to use questions that are up to industry standard. And that's the way that most automotive industry certification tests are. They have a lot of Tech A, Tech B style questions. The easiest way to figure these out, the way I break these down, because I'm a horrible test taker too, but I get through them. And a guy showed me this, told me this a long time ago, and this is the way I do it. I take a Tech A, Tech B question, I break it down into two separate true or false questions. So I'll look at Tech A says blah, blah, blah. I stop, and then I think, is he right or wrong? And then, you know, I'll put a T or an F next to Tech A, whichever, if he's right or wrong. And then I read the next part of it as a second question. Tech B says blah, 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 and I stop, and I think to myself, is Tech B correct? Or is he wrong? And I'll put true or false next to Tech B. Then I have my answer, because then it's going to ask you, who's correct? Both, neither, or just one of them? So now you know. So that's the way I break it down into two separate true-false questions. I found it works for me. It may not work for you, but that's the way it works for me. So that's a little tech tip of the day for taking ASE tests, because you guys will take ASE entry-level certifications here throughout your program here and get patches and some certifications as an entry-level tech. All right? So, number one, Tech A says thread insert can be used to repair damaged internal threads. Tech B says a thread file may be used to repair lightly damaged external threads. Who's correct? Tia, on the keyboard again. C, you got it. You got it. Both of them are correct. You can use a thread insert to repair damaged internal threads, and you can use a thread file to repair lightly damaged threads. Number two, Tech A says to use heat to help remove a broken fastener. Tech B says that broken bolts mean the part must be replaced. Who's correct? Hunter. Man, he was on the keyboard that time. Those keys must be on fire. They're smoking over there in your houses probably, because you guys are right on those keyboards fast. All right, so yes, the correct answer, Hunter, you're right, is A, Tech A. Tech A said that you can use heat to remove a broken fastener. The old heat wrench, I call it, the oxyacetylene torch, works almost every time. It's amazing putting a little heat to something, how it'll come apart. Tech B is incorrect, because when you have a broken bolt in something, you don't necessarily have to replace it. If you know how to fix it, you can fix it. All right? That one was Hunter. All right. Number three, Tech A says a grade 5 bolt has 5 hash marks on the head. Tech B says the diameter of the bolt is measured across the outside diameter of the thread. Who is correct? I gotta look at the screen. Ooh, Hunter again. All right. Yes, and you're correct, Hunter. B. Technician B is correct. So Tech A says a grade 5 bolt has 5 hash marks on the head. That is incorrect. All right. A grade 5 bolt has 3. Always remember, a rule of thumb, if you don't have this chart with you, a rule of thumb is add 2 to the hash marks. All right, so if it has 3 marks, you know, you add 2, that's 5. All right, so good job on that one. Number 4, Tech A says when heating a broken fastener, induction heating works best. Tech B says that oxyacetylene torch may cause damage to other components. Who is correct? Hunter, you were first on that one. Got it. All right, and you are correct with C. The answer is C. Tech A says when heating a broken fastener, induction heating works best. It doesn't say it's the only way to do it. It just says it's the best way to do it. That is correct. Tech B says that oxyacetylene torch may cause damage to other components. That is also correct. I I know I tell you guys all the time, I tell you my mistakes. Sometimes people don't want to admit their mistakes, but I've learned a lot from my mistakes, and I hope that you learn a lot from my mistakes. I have melted bushing because I was too close to something and didn't realize the flame wasn't pointed at it, but it was hot enough around there where all of a sudden it started to distort the bushing when I was learning. So over the years, I've learned when to use a torch and what to use a torch on and what not to use on, and how hot to make the flame or how big to make the flame, because you have to be very careful. Remember, there's fuel lines, and a lot of fuel lines on cars nowadays are plastic. You can melt right through that and have a heck of a problem, all right? So the answer to that was C. Moving on, we're knocking this out, and then we'll be done here in a few minutes. Tech A on number 5. Tech A says torque angle means the fastener is torqued to a specified torque and then turned to a certain number of degrees. Tech B says torque to yield bolts can be reused because they're made to stretch. TL on that one. Man, that keyboard's on fire. You got it right, too, Tia. The answer is A. Tech A says torque angle means the fastener is torqued to a specified torque and then turned a certain number of degrees. So we have torque angle torque wrenches here. We have regular torque wrenches, and then we have digital snap-on torque angle torque wrenches where we may do, like on, I was doing a lot of LS cylinder heads when I was in the GM garage. I'd put pistons in engines for oil consumption, different things like that, put heads on. We had a while there where we had some cracked heads. You know, I don't remember the exact specs off the top of my head, but there's a procedure where you put the torque, you put the new head bolts in, you have to torque it to do all your passes, and let's just say like, 90 foot-pounds. Then you have to go back with another pass and maybe turn it 90 degrees or 180 degrees or 40 degrees, whatever the spec is. So you torque it to a set foot-pound or torque spec, and then you change the torque wrench over to torque angle. We also have here torque angle gauges that clip onto the extension or the socket that you can use. Old style, new style, I'll show you both ways. And then you turn it at certain degrees, and that's what puts that stretch in that bolt. That's what takes it past the yielding point, all right? All right, number 6. Tech A says fasteners should always be lubricated when tightened. Tech B says lubricating the fasteners will change the clamp load of the fastener. Who's right? Hunter threw in there. Hunter, you're first, but we want to look at that answer again. Tech A says, let's start and break this down real quick. Tech A says fasteners should always be lubricated when tightened. That's not necessarily true, right? Some fasteners, redemption. All right, Hunter, yep, you redeemed yourself there. The answer is B, because like I said, Tech A says fasteners should always be lubricated when tightened. That's not true because it says should always. It's the wording. Yes, some fasteners maybe are required to have some sort of lubrication on them to torque them down properly. ARP performance, like bolts when you're doing a performance engine stuff. When I put ARP bolts in any of my, Pontiac motors or anything like that, ARP recommends on a lot of their fasteners to install a special torquing compound. And that's what they recommend, and they say that that is actually gives a more accurate torquing force. Some bolts say no, don't put anything on it. So that's wrong because it says should always. Tech B says lubricating the fastener will change the clamp load of the fastener. Tech B is right because if you do lubricate it, it changes the torque load. All right, and that's why some companies want you to do that depending on what application. Like I said, ARP, I always use there's a torquing paste, a compound you put on there to torque the bolts down. So Tech B is the answer on that one. So Hunter, you got it. Then you came back and redeemed yourself, so you got that one. 7, Tech A says non-threaded fasteners are designed to firmly clamp parts together. Tech B says a cotter pin is designed to be reusable. Hunter, first in with the correct answer. Correct answer is D, neither are correct. Tech A says non-threaded fasteners are designed to be firmly clamp parts together. If they're not threaded, they're not going to have any clamping force, all right? Tech B says a cotter pin is designed to be reusable. They are not. A cotter pin, you pull a cotter pin out, throw it away, get a new one. They're a couple cents. I mean, they're not that much. I have bins full of different sizes back here. Don't reuse an old cotter pin, all right? Little tech tip off to the side for Pennsylvania State inspection. If a cotter pin is missing out of a steering or suspension component, that fails inspection. I know that because that's one of the bugs that I sometimes use on the state inspection classes here in the evening classes for adult education. Sometimes it's as simple as just a cotter pin being missing out of a tie rod end. They're important to keep that. That's a locking feature to keep the nut from coming loose. All right. So you want to make sure you put a new one in every time. Number 8, Tech A says it's essential to wear safety glasses when working with snap rings. Tech B says that roll pins are typically used to hold one part to another. Who's correct? Hunter. Hunter, you got it. All right. And C. Hunter is the first in with the correct answer. When I say first in with the correct answer, it doesn't necessarily mean he's the first in. He's just the first in with the correct answer. All right. So it is essential. Both are correct. It is essential, Tech A says, to wear safety glasses and work with snap rings. Yes, I can vouch from experience doing transmissions in a dealership. They're all held together with snap rings. You take a snap ring like this and use a special tool to spread this apart, to slide it over something to fit in a groove to hold it together. These things have a tendency to slip out of the pliers and fly off. I've had them come up, hit me in the safety glasses, hit me in the face. You definitely must wear safety glasses when you're messing with snap rings. All right. And Tech B said that roll pins are typically used to hold one part to another. That is correct. Let's see if I have a roll pin. All right. This will actually go inside of a part and hold parts together. It's just press fit. All right. So the answer to 8 was C. Number 9, Tech A says that lock washers are usually considered to be reusable. Tech B says washers are graded the same as nuts and bolts. Who's correct? Tech A says lock washers are usually considered reusable. Tech B says washers are graded the same as nuts and bolts. So that's correct. I'll give you guys a few seconds here. That's kind of a tricky one because I guarantee you're thinking right now, especially about the lock washer one, what Tech A says. Ooh, last second. TAN. Not the exact correct answer, but close. It is very close. Hunter, that's okay. I see your message there. Your computer died. No problem. All right. Shane, yes, I am going to want these turned in. Hang tight, all right? I am going to want you to submit these to me, all right? You can make the corrections on there. Go from there. All right, so back to number 9. Number 9, Tech A says lock washers are usually considered to be reusable. Tech B says washers are graded the same as nuts and bolts. The answer to that one is going to be B. All right, the answer to that one is going to be B. So, and then Hunter, I saw you come in with it right as I was saying it. All right, I appreciate that. Tech A says lock washers are usually considered to be reusable. That's not necessarily true. Have I reused them? Yes, I have reused them, but theoretically, when you're here going, I have plenty of them. You go get a new one, put it in. Once you use it and it clamps down, it's kind of lost its spring tension a little bit, so you want to get a new one. Tech B says washers are graded the same as nuts and bolts. That is true. There are different grades on washers too. All right, so that's a tricky one. So last one. Tech A says a lower grade bolt can be used in place of a higher grade bolt. Tech B says nuts should be the same grade as the bolt. Who's correct? Tia, you got it. First in with the correct answer. Good job. B, technician B. Tech A says a lower grade bolt can be used in place of a higher grade bolt. That is not acceptable. If anything, it should be the other way around. You can use a higher grade bolt in place of a lower grade bolt. So if I took a grade 5 out and I only had a grade 8 in that size, that's okay. You're putting a stronger bolt in. You want the same or better, equivalent or better. You do not want to go lower, okay? An engineer made a lot of money to figure out that that grade 5 bolt needed to be in that spot. So you always want to go with the equal grade or higher, okay? So good job, guys. I got a list here, Mr. Highlands and myself, who knocked this out. We're going to tally this up, and I will post a little message on Schoology here in a little bit of who won. I mean, it's come down. I mean, it's between Hunter and Tia. We're going to count it up. I'll put a little post to see who won. And then when you guys get back, hold me to it. I'll forget. Hold me to it. I got some little free giveaways and some little knickknacks here for you guys. All right. So make sure you claim your prizes. Now, yes, I had a question up there. Do you still want these turned in? I absolutely do. If you made corrections on it, you marked it wrong, and you marked the right answer, that's fine. I'm not grading you on your accuracy on this. That's what the test is for. This is a study guide. This is a review session. All right. You're not here in front of me, so I got to try and do it in different ways. Yes, I want you to turn it in. I will give you a completion participation grade for that. If you did it, you're getting a point. All right. I'll give you 10 points for doing it. If you didn't do it, you didn't do it. You get a 0. All right. So please turn it in to answer that question. All right. Now, do we email it to you? Yes, you can just go ahead and email it right to me. It's just easier. Just email it and we'll be done. All right. I like that. Good question. Good question. Thank you, Shane. You can just send it right to my EWCTC email. I'll save it in a folder on my computer here for you guys. I'll mark the grade and you're good to go. All right. Before I let you guys go, does anybody have any other questions? Take you over and show you a little something and see if we got any questions. Got something a little different in here today. All right. Customer's car I've been working on. Brought it for a final test drive before we load it up. Take it back to Virginia. Drop it off. Doing some final checks on the EFI conversion. Let's tune a little bit on cold starts and hot starts. I should have it dialed in today. And I want to check a few other things. But I just wanted to, before I let you guys go, I just wanted to give you a quick little close-up on the GTI. I know some of you guys saw it before when I brought it in. But I'd show you guys some little different things we bring into the shop. Not every day you see some stuff like that. All right? All right, guys and girls. You're all done. Have any questions? Finish up your assignments on Schoology for the day. Get all your other schoolwork done. Get out there and enjoy the weather. I believe it's still beautiful outside. I'm going to open these doors up myself here in a minute, get a little fresh air in here. Enjoy the day. Have a good weekend. Make sure you get that test done. I have it out till Sunday at 11:59 before it closes. So if I was you, I'd try and get it all done today so you can enjoy the weekend. All right? Have a good one. Stay safe. Good job. I appreciate your participation. I'm proud of you guys. All right? Wortman out.